Okay, so now we look at the impulse momentum, a new topic for us. The impulse acting on any body is is closely related to the change in the momentum of the body. Now, this is a very basic Newton's law, which is summation of all the forces is equal to m. Now, suppose you know we differentiate this equation, so we can write acceleration as dv by dt, which is change in velocity per unit time. Now, this is uh, this equation now will convert into two instances where we have where the body is moving or is subjected to some force from time t1 to t2, and there is change in velocity from v1 to v2. From v1 to v2. So, in the integral form, it can be given as summation of forces uh, at time from time t1 to t2 is given by m into. Now, this can be written as this is the change in velocity, so it can be given as v2 minus v1, and now summation of the forces from time t1 to t2. This can be given as, since this is the change, the velocity in integral form can be given as changing velocity from v2 to v1, and the term existing here would just be dv. So this is a basic equation. Now, the x and y. Suppose for all practical purposes, we use the x and y coordinates. This is the x-axis and this is the y-axis. So, writing the same equation for the x and y components, we get summation of forces, summation of integral forces from t1 to t2 fx would be m from v1 to v2 or v2 to v1, and you can write, it will just change the sign of the answer, v1 to v2, and this will be x. And similarly, for y component, taking integral from t1 to t2 fy would be m, that is the mass, and integral of this would be. So this is just a different form of representation of the original signal. Now, the important part here is the law of, or just write it down here, law of conservation of momentum. So, according to the law of conservation of momentum, the momentum of a body at initial stage would be same as that of the momentum at the final stage. So, it is given by summation of mi uy, where u is the initial velocity, the same as summation of momentum at the final instant, that is v is the final velocity. And again, this can be represented in the form of x and y component. So this term would become x and y vx, and for y component it will be vy and vy. So same equation can be used for x and y both. The same equation can be used to find the values of x and y components. And now we look at the sums that are associated with these topics. Okay, so now we have a sum based on impulse and momentum. It is given to us that a cricket bat hits a ball and the velocities before and after the collision is given. So before collision, when the ball is coming towards the bat, is 50 meters per second, and after the collision, the velocity of ball is 80 meters per second. The collision lasts for a time duration of 0.05 seconds. Find force exerted by bat on the ball. Assume that the mass of the ball is 0.2 kg. So we have to find the force. So now, this is the diagram that is given to us in the question. This is the bat, the ball coming and hitting the bat at an angle of 10 degrees, and after hitting it goes with an angle of 30 degrees. The velocities before collision is 50 and after collision is 80 meters per second. So now, this is the basic formula. Impulse is equal to the change in momentum. Impulse is given by force up into the time period, and change in momentum is given by m, which is the mass, and change in the velocity. So the time period, the time of collision is given to us, which is 0.05 seconds. We write here 0.05 seconds. The mass of the ball is 0.2. Now, V2 is the velocity after collision. So this is what V2 is. So the x and y component of velocities are written here in the form of I and j. So the x component would be, if you resolve this force in vertical and horizontal component, the x component would be 80 cos 30 cos of 30 degrees, and the y component would be 80 sine of 30 degrees, and minus the velocity before collision. So before collision, if you resolve this one, so the x component and y component would be this way. The x component is pointing towards the negative x-axis, so this is taken as negative. 50 is the velocity and 10 is the angle made, so it is minus 50 cos 10 I, that represents the x component, plus 50 sine of 10, and this sign is positive because it is in positive y direction. The y component is upward, so this is positive and this is 50 sine 10. So when we solve this equation, when we solve this entire equation, we get the value of force as 474.08 I, that is the x component, and 125.28 j, that is the j component of the velocity of the force. Sorry. So we have the two forces with us now. Now we have to find the magnitude of these forces. It is given by ith component, the square of ith component, that is 474.08 square, plus the j component, that is 125.28. So this is the j component, and you take the root of these values, so we get our magnitude of the force is given by 490.35 newtons, and the angle is given by the j component, that is tan inverse of j component, that is 125.28, divided by the ith component, that is 474.28. So when we solve this in our calculator, we get the theta as 14.08 degrees. So this is an entire sum that covers the impulse and change in momentum and the conservation of momentum part of this syllabus.